Hello and welcome. In this presentation, I'll discuss what is process analysis and what are the tools and techniques that are available for analyzing processes. Now, process analysis is the documentation and detailed understanding of how work is performed and how it can be redesigned. So, in some way, we want to ensure we have an overall understanding of how the process is currently being done and what are the changes we can make. To be able to do that, we have to systematically document it so that we can understand it in detail. Now, once we have an understanding of the process, obviously process improvement can be made. And this is a standard Six Sigma process improvement model, which just tells us the stages that we typically go through to improve any process. We would always need first to define the process, which is what exactly the process is doing. We need to have the right metrics for the process. So how do we measure whether the process is doing well or not? Then we need to analyze the process, which is the process analysis step that we are currently talking about here. Using the process analysis tools, then we will understand what are the opportunities to improve it and then make some changes to the process and thereby try to improve it. Once process improvement has been accomplished, then the objective would be to control that process in the improved state. So that's something which, again, it's a repetitive cycle where we keep on ensuring that we have maintained the control, and if any other additional improvement can be made, we continue improving that process. Now, to document and evaluate the process, there are different tools available. We have flowcharts, we have work measurement techniques, we have process charts. Now, we'll look at flowcharts and process charts in detail. Work measurement techniques essentially refer to the techniques where there is time study, time and motion study, where somebody actually tries to understand what are the work elements involved in a given process, what is the time that is taken to complete that element, and then using that, we can then determine what are the kind of changes that can be made for a particular work that is being done. So there are several formal techniques that will fall under the process improvement or process documentation, which fall under the work measurement techniques, and something which many organizations are incorporating as part of their understanding of it. It could include elemental standard data method, which is basically when products or services are highly customized. In those cases, you're using some standard data, which is a database of some standard that the organization has compiled for itself. It could have some learning curve analysis, which basically captures the idea whether these processes have any learning curve effects. Do these processes get done at a faster rate once people have been doing it for some time? So again, that is part of the overall work measurement techniques. Several kinds of techniques that exist under that. Now, for flowchart, essentially it's a diagrammatic or a pictorial representation of the flow of information, customers, equipment, or material through the various steps that comprise a process. In the case of services, we have a special flowchart. We call that service blueprint. And what it does is it basically distinguishes those activities or those steps which have high customer contact versus the ones which have low customer contact. So there's a way to segregate these steps in a certain flowchart called service blueprint. Now, this is an example of a flowchart. We call it swim lane flowchart. Essentially, what it does is it creates a visual representation by grouping functional areas that are responsible for various sub-processes in that lane. So we have different lane. One of the lane is customer. We have sales, we have operations, finance, and marketing. And this is an example of order processing. So there's an order which has been placed by this customer. Customer has submitted this order, and how that acceptance process works within a company. So we see that the customer submits the order, there's a request for quotation, and then sales will prepare the quotation with standard terms, submit that quotation back to the customer. Customer will respond to the quotation. So far, the interaction is only between customer and sales. Once the response has come from the customer, the question will be whether the customer has accepted the quotation or not. If the customer has accepted the quotation, which is what we have here, then that order has to be provided to the operations manager for review to understand whether we have the inventories or not. Can we actually process it? And if it has not been accepted, then there is some more interaction between the sales and the customer. That is, revised orders are being sent. So as we see, there is a lot of interaction between customer and sales in the upfront. Then there is between sales and operations. And hence, what we are seeing are different steps and linkages between steps, which provide us understanding of opportunities for improvement of either the steps or the linkages that might exist. So this helps us understand through a visual representation how things are being done for a given activity. Process charts. These are organized way of documenting all the activities performed by a person or group at a workstation with the customer or with certain materials. And we'll see that there is a way in which we pictorially again represent these activities and then also put some time and distance estimates for how these are being done. Now, typically, there are 5 categories that we can put these activities into. They're either operation, something is being done on some input. There could be transportation, things are moving around. There's an inspection of uh, products, materials, whatever is going on. There's a delay involved, or there's storage of items within the process. So we'll take this example of a patient entering into an emergency room, and we want to categorize different steps based on whether it's an operation, transportation, or any of the other things that we saw in the previous slide, and determine what exactly are the times being spent in these different kinds of activities. So, for example, here the patient enters the emergency room and approaches the patient window. This will be an example of what we will call a process, which is more like a transportation. We'll see later that we will start putting those selections over there. Next, this patient sits down and then fills out the patient history, which is not movement, rather it's some kind of an activity input converted, transformed to some output. So a blank document being converted into one which has the patient history. So it'll be more like an operation setting here. So we will see that we actually can then create a list of all the steps involved from the time the patient enters the emergency room to the time when the patient leaves the building, and then appropriately categorize these steps in each of these columns depending on what that step is doing. As a next step, we could understand how much time is being spent by the patient doing these kinds of steps. And then that is what we can list on in these 2 columns here, the time as well as the distance traveled. Distance traveled will be relevant only when there is a transportation activity. So whenever there is some movement, that will have a consequent uh, relative distance that they have to move within that emergency room or within the hospital. Once we have this understanding, then we can aggregate them. We understand how many operational steps are there, how much time is being spent, how many transportation related steps are there, how much time is spent, and how much distance is traveled in that. And likewise for inspection, delay, and storage. In this case, there's nothing which is getting stored. So this kind of gives us an understanding of what's going on with different processes, what are the number of steps involved and how much time is being spent, which then gives us opportunities for improving these processes. So these process charts then can actually be used to determine the annual cost or estimate what is the annual cost, labor cost, for example, for the entire process that is being done. Essentially, it's a product of the time in hours to perform the process, each time which is to be done, and then variable cost involved per hour for the labor, and the number of times the process is performed each year. So if we know these different aspects, then we just multiply them to get, for example, the average labor hour in this case. So very simple example here. If the average time to serve a customer is 4 hours, the variable cost is about $25 per hour, and there are 40 customers that are served every year, then total labor cost will turn out to be $4,000, just a multiplication of these 3. So that's the same kind of things we could have done in the emergency room example using the process charts value that we got. Now, Data analysis tools are very important to really understand exactly how everything is working within an organization. And we will be using some of these tools in an example to understand their efficacy in managing process and improving process. So essentially, we have checklists as one tool, histograms and bar charts, Pareto charts, scatter diagrams, cause and effect diagrams, which also are called fishbone diagrams because of the way they look, and certain graphs that we can create. So we will see an example to understand how these data analysis tools can come together to help an organization to improve their process, analyze their process. So this is a company, Wellington Fiberboard Company, which produces headliners, the fiberglass component that form the inner roof of passenger cars. The management wanted to identify which process failures were most prevalent and to find the cause. So what they did was, first step, they created a checklist of different types of process failures for the last month's production records. Second step, they put that into a Pareto chart, basically in an ascending order or a descending order in terms of how all these different process failures turned out. Step three was to create a cause and effect diagram or a fishbone diagram to identify several potential causes for the problem. And step four was to reorganize the production reports into a bar chart according to the shift in which these occurrences were happening, morning shift, afternoon shift, etc. Because personnel who are operating in these three shifts have different amounts of experience. So there's some reason to believe that that could be affecting the output or the process failures that might be experienced by the company. So the example of a checklist, it looks something like this. So here, for example, the headliner failure is the key problem that they have, and they want to understand what is the cause for it. So they found there are four potential process failure causes here. One is tears in fabric. They found four instances of that. So that's what you see here in four instances of tears in fabric. They also saw discolored fabric three times. So that's three instances of that. Broken fiberboard by far was the maximum occurrence that we see. 36 times they observed this occurrence of broken fiberboard, and ragged edges 7 times. So in total, they saw 50 failures in the last month's production reports, with 36 of them being contributed by broken fiberboards. Next, they put that into a Pareto chart. As you see, it's a descending order where the C, which is essentially the fiber board which is broken, has the highest number here. And that's the idea of Pareto chart, is to basically put that in a sort of bar graph, histogram, but in a descending order of occurrence. Then you have the cause and effect diagram. This looks like a fishbone diagram where the broken fiber board is your main problem, which is what you saw as the main reason why process failure was happening. So you take that and make that the head of the fish bone or fish structure here. And then essentially each of these bones that you are trying to put here, all these different cause and effect diagram bones, are capturing the key reason why broken fiber board exist. So there are some reasons that are people related reasons. There are some reasons that are process related reasons, some which are material related reasons. So for example, people related reasons are training, lack of training, or absenteeism, communication issues. Process related are maintenance issues, speed of machine, wrong setups, and materials could be out of specification, they're not available. So these are basically capturing what are the different things that could be causing this. And once you have an understanding of the cause and effect, then a systematic approach can be taken to ensure that these issues are then addressed appropriately. And then the last step was to put them in a bar chart in terms of the shifts that are involved. So we see that the second shift clearly has a lot more of these defects than the first and third shift. So then the question would be that there is a lot more of these process failures in the second shift, and majority of the process failures are in the form of broken fiber board. Together, why is it that we have employees who are potentially less trained or more absenteeism that is going on in second shift? what are the reasons why machine maintenance issues or machine speed issues are happening a lot more in second shift. So we try to combine these different findings into an aggregate understanding of what's happening with the process. So this is how we analyze processes. And then once we have analyzed it, having a good measurement for the process, we can then ensure that we take steps to improve the process. So overall, in this presentation, you got an understanding of what process analysis is all about and what are the tools and techniques that are available to analyze processes and then improve them. Thank you.